Scientific notation, you should have had this in like chemistries and biologies and physics and all this, so I'm going to do it real quick. Okay, scientific notation, where A is greater than or equal to 1 and less than 10. What does that mean? That's just one number. Okay, it's 2.3. It does not equal, you cannot have 23 times 10 to the 5. Because your A is bigger than 10. Okay? It has to be a single number. Okay? We do this a lot in astronomy, deal with very large numbers, very small numbers. Okay. Converting. Pretty easy to convert. I will refresh your memory if you don't know. Okay? I'm going to convert this, so I start here and I go 1, 2, 3, 4. So that's 1.4 times 10 to the 4th. Well, you can't go between the 4 and 2 because I just got done telling.
Wouldn't it have to be 1.42?
Oh,
you can't just drop
I'm sorry. Okay, that gets into the whole significant digits. And we're not going to go there right now. Okay. Again, this one you would go 1, 2, 3. So this would be 4.2 times 10 to the negative 3. Okay? Any questions on that? You're just counting over. Okay?
How do you know how much you found? I didn't know that.
You just start here where there's no number, and you go to in between these two. So if I had 1/6 million, something like that, I start here at the end of the number 1, 2, 3, 4, 5, 6. Remember, because my A can only be one number. So this would be 1.6 times, I already forgot how many. 6? Just like that. Okay. All right, now you can convert back to standard notation. I'll let you do that. Okay, to switch it back to standard, basically you're going to take your number, and the way I do it is I just go 1, 2, wait. Let me do it the right way. How many over do I have to go? 5. Okay, so how many zeros do I have to add? 3. Okay, so then I put 321,000. Okay. Oh, going this way, I have to add 5 zeros. Megan, you're annoying me. Oh. Now, this is the power of scientific notation. If we did not do scientific notation, I would have to take, I don't know, who has a nice TI-83 in here? Let's see, I need 4 zeros. Go ahead and multiply those together on your calculator and see what you get. You're going to get an error, I would assume.
The 370 or
370.
7.77E12.
Now, this is the calculator's answer. Go ahead and say it again.
7.77E12.
That's how your calculator, unless you set it up to do scientific notation, is going to give you scientific notation. Okay, so when we multiply these, we better get this answer, which turns out to be 7.77 times 10 to the 12. Okay, calculators don't naturally do that. When they throw an E in there, and that tells you 12 zeros. Okay, so we don't want to do that all the time. Imagine if we didn't have calculators, we had to multiply these. So when you multiply them, basically you're going to take these two times each other. Okay? And hopefully you get 7.77. So you take that 7, 7. Now you're going to multiply the tens. And how do we do that? The bases are the same, so we do what with the exponents? Add them. And that's how you multiply really big numbers. Okay? Now we can also divide them. Again, you take these numbers and divide them first, and then we're going to worry about these ones. So you're going to take 4.96 divided by 3.1.
1.6.
1.
1.6.
1.6. Okay? Now we're going to have to do the tens. Okay? Now if you know your negative exponents, we can bring this to the top and make it 10 to the 7th. Okay? So when we multiply a big number by a really, really small number, not bigger, which it should. Okay. I want you to try that one on your own. Now let me show you the easy way to do this, okay? We can just put an exponent here, right? A 1. We bring our 3 in. So I'm going to get 1.8 to the 3rd power times 10 to the negative 12. At this point, we have to figure out what 1.8 is cubed. And what's that, Caitlin? 5.832? And that would be your answer. Okay? All right. I have another example for you. I would like you to do this one. Be careful. So again, the first thing we're going to do is we're going to multiply these two, and I don't know, whoever has a calculator, what is it?
It's 228.67.
0.67. Okay, at this point I'm going to stop. That's not scientific notation because it has to be a single digits. So at this point, I'm going to go ahead and convert that to scientific notation. Because I can never remember, do I'm supposed to add a 1 or subtract the 1 of the exponent. So I'm going to do it this way. So now I have to worry about all my tens. 10 to the negative 3rd, 10 to the 9th. Okay? So I add the exponents. 1 plus negative 3 is negative 2. Negative 2 plus 9 is 7. So it turns out to be 2.86 times 10 to the 7th. Now a lot of you had this answer. Okay? And I guess some of you knew that if you went this way, you just added 1. That's fine. You can do it that way too. I always seem to forget that I'm supposed to add or subtract, so... You know, the kids will say if you go to the left, you add this. If I have 0.28, I go this way, I would subtract an exponent. Okay? That makes sense. You can't have this. So, we good? How much time do I have?